So thanks, Javier, first for inviting me and also for introducing me to this talk. I will say a few words more about me in a couple of slides. So I'm going to be talking about the Uncharted side of not your data, but data we collect for other purposes, and how can we take benefit of it in software engineering organizations, right? Yeah, last time I was presenting in LaTeX, things were a bit different. This is a picture of me presenting the work I was doing with Javier there. This was 6 years ago, next week. So yeah, I have more or less the same hair, so nothing big changed. Well, I would say also what changed on me, but so as Javier said, I have been recently promoted to associate professor in BTH. I'm also program manager in a 5-year program in software development, in which I also teach software engineering first course in first year for that program and other 2 programs. Few words more about me. I studied software engineering in Valencia in the 90s, and then I did my engineering degree and master's and PhD here in Valencia in Spain. Before that, I was working in industry for more than 10 years. As I said, I did a PhD. I was a postdoc in LaTeX, and now I consider myself a researcher / practitioner, and not always in the same order as we were discussing before with Javier. Now I'm working a lot with industrial PhD students, and sometimes I mean with a bit of imposter syndrome, but because you end up supervising people that were senior developer or architects when you were in the high school. But yeah, that's how it works in these days. So I collaborate doing applied research with several companies in Sweden: Spotify, Ericsson, Volvo Construction Equipment, Fornox, and Swedbank, among others. So I have also other sites as the data I'm going to talk about today. I loved doing sports, but this is kind of deprecated since 2018. So the biggest change in my life is that I'm now the proud father of 2 identical twins with all the challenges that this brings, and they keep me busy. And we talk a lot about software clones in software engineering, that as they are bad, but clones can be also adorable. And those 2 are really adorable. They are now playing around outside because here is 6:30 p.m. and they are like playing in the park. So yeah. So 2 words about BTH, Blekinge Tekniska Högskola, or Blekinge Institute of Technology, is super small university in a super tiny village that you can see here, with 21 programs. But however, we are a super strong research environment in software engineering. We are 7th in the world and first most active institution in software engineering research in Europe, according to ESS. And now I'm going to, as I said, I'm going to be talking about, now I'm going to jump into the bulk of the talk. And it's this Uncharted side of data and things we can learn about it. So, so nowadays we are gathering constantly vast amounts of data, and organizations are hungry for data, and sometimes they collect data they don't even know what for, right? And today's we are on the days of big data, but I think we better move to the days of better data, right? Because nowadays it's sometimes very hard to do or meaningful analysis out of the data we are collecting. But sometimes you can give another angle to the data you already have, and you can learn quite a lot of lessons out of it, right? So, and that's what I'm going to try to do today. So what data we are talking about? I'm going to be talking about normal data software organizations collect, like Git, Gerrit, Slack, even calendar invitations, and Sonarchy, which is a bit more complex. So Git, I mean, most of us, we know what it is. It's a version control system that allows us to control file changes over time, and also have different configurations, and basically organizations control the code they produce with it. When developers commit or push some code to the main repo is what we call a commit and a push, and that's integrated in the final version usually. And we get data from their authorship, data files that were changed, size, etc. This is what we are going to be using. Gerrit is a code review tool that allows organizations to keep software quality or use it as a software quality assurance mechanism. And code review is the act of inspecting code being committed to a repo, right? And it's supported by tools like Gerrit. And from Gerrit, what we want is who produces the code, who reviews, the verdict, the time that it takes from the time that a developer says, I'm done, until the time that somebody reviews and says, it's okay. And that's the data we get out of it. We also will use Slack messages. Slack is a communication tool for professionals and is mostly used by software developers, but not only, of course. There are public and private channels, and people can subscribe to them, and then they get offline communication through it, and also allows point-to-point communication. I don't think I shouldn't say anything about meeting invitations after we ran into the pandemic, but are used nowadays to book meetings, and it includes information about who organizes the meeting ID, whether it's recurring, meaning that it occurs each week or every second week, and whether I have accepted, etc. Right? So that's kind of trivial nowadays. And finally, SonarQube is that's probably a bit more technical tool that allows us to reason about technical debt. That is a metaphor that allows, so we use in software engineering to discuss long-term consequences of suboptimal decisions that we take when we need to be fast. There is a need for this. However, technical debt seems to be an umbrella for all technical consequences that occur nowadays in software engineering. And usually what happens when you talk about it is that everybody says, yes, we have a lot of this in this organization, but nobody knows about it, right? But that's another issue. So mainly technical debt, what happens is that you become slower. Sometimes in organizations, we hear, I don't understand why it takes so long, right? That's technical debt. That's the consequence, but that's, as I said, another issue. So what I'm going to be using technical debt today is to reason about issues, code smells, bugs, vulnerabilities, where each issue has been found, severity, and most important, the expected remediation time for each issue, how much it will take for a developer to fix that. And with this data, I'm going to be talking about what would change in our ways of working during a pandemic. And this is going to be the tale of two big cases. I'm going to be talking about two companies. I cannot mention the names. If you dig a bit, you might understand who they are, but I can, for confidentiality reasons, I cannot mention. But the first company is 2,000 engineers located in Sweden, UK, and USA. They have sites in more countries, but the bulk of the development work is done in these three countries. And I'm going to be using volume of code produced in Git, calendar meeting invitations to understand calendar patterns, number of meetings, duration, time spent, etc. Slack communication. And we will also try to blend all this data to understand work patterns, how the daily routines changed in the pandemic. And in company B, we are only analyzing a part of the company. Indeed, we are focusing in one particular product that is developed in Sweden, Brazil, and India. I will use volume of code, deployment history, and time to deploy. And also we will merge or blend some data to understand work patterns. We are going to be looking at the amount of code produced, and this is important. We are not using this data to try to measure productivity. So we only use it to measure the volume of code being produced to understand what's happening in the company when we move to working from home. So this is the two companies and what happened in the 2019 versus 2020. And when we look at it, we see that there is no big difference when we moved to working from home. Here we flag week 10 in 2019, when we moved to working from home. And we see that the volume of code produced in the company remains the same. Same more or less it's happening in company B. So we have different weeks in which the people went home, but we don't see big differences when it comes to code produced. And we tested this for statistical significance, and we don't see differences on the volume of code being produced. However, one can be tempted to say, yeah, what happens if you add more developers to both organizations? So we normalized per developer, and what we see is that both companies increased the volume of code being produced by developer per week. So things seems to be following the same pattern. So if I zoom in a bit, I can analyze developer by developer. So in this is the big organization, company A. This is the product we are analyzing in company B. Each dot represents a developer. Y-axis is code being produced while working from home, and horizontal, it's code being produced while in the office. If you are above the diagonal, means that you are producing more code per week when you were during the pandemic or working from home. And if you are below, means that you are producing less. So both companies are every developer, or not every, 54 per developer in this case, and 62 are producing more than when working in the office. We, at some point in time, I think it was the end of 2020, I ran this analysis, and interestingly enough, both companies had exactly the same percentage of developers being producing more code, which I find fascinating, right? So another thing so we kind of put the different developers in different bins. So here is 25% developers. This is 50%, and this is 25. This is the quintiles, right? And we call this occasional contributors, right? They contribute quite a few, so very little per week. And these are the people who is committing most of the code. And what we saw is that we have people dropping significantly here. We did interviews, and what we figured out is that those developers, what happens is that they become enablers for the people that were occasional or core contributors, and then top, what we call also in some organizations, pioneers of the product, they become kinda enablers only. They end up committing or developing very little, but they are the ones that make things possible, right? And that happens in the two organizations we studied. So we, on top of doing quantitative analysis, we also did a lot of interviews. The paper is on archive. I will tell the story of that paper if we have time at the end. Yeah. And then we analyze the number of deployments. So, yeah,
Javier?
You can stop me when you want. Yeah, sure. Have it.
Yeah, I want to make sure I understand. So you said the people whose productivity dropped when they worked from home are the enablers. Is that what you said?
From top contributors. So from this,
yeah,
from this part.
Yeah.
So a lot of, if you see here, there are a lot of top contributors that dropped. And this, when we talk to them, it turns out that some of those are the people enabling. I mean, some of those were like architects in the teams or people that were doing a lot, but then they stopped developing that much and become enablers or supporters to others, right?
So does that mean when they are working from home, they are producing more code? When they are at the office, they are
No, so these enablers, what happens is when they are working from home, they cannot work that much.
Okay.
This part of the picture.
Okay.
Right. This part of the picture means that is people that now working from home, they are more successful. Okay. And this, when we analyze it in offshore offices, it turns out that before they were working in another way, and now they don't have the supporters in the office that you can knock on the door and ask. Yeah. And therefore, you need meeting time, etc., to enable. Another thing that we observed, and this is another paper that I'm not authoring because I was not part of this interview study, is we analyzed what happened with pair programming. And but some of the developers in other cases I will present later reported that they pair less and mob less, and this had a significant effect on the quality of the code being produced in some particular components. I will talk about that later. Okay. Yeah, the deployments per week. I don't know if you know this book, Accelerate by Forsgren, but one of the metrics they report to be super successful to measure how the things are going in a company is the number of deployments per developer per week. We measure that, and it turns out that 2020 seems to be a bit better than 2019 in the organization in Company B, where we were able to measure this. So things doesn't look that bad. So one of the main consequences of code production in organizations is nothing really changed when we move home, right? The main question that remains is quality, but that's what we are doing now. Or we also analyzed what happens in terms of what type of work people is doing. And this was a surprise for me, because people tend to be refactoring less. So this is top is 2020, bottom is 2019. People refactors less and seems to be working on fixing bugs a bit more. We cannot say that those bugs have been produced or are due to the code that has been developed during the pandemic or during working from home, but sounds strange, right? So that's another part of the future work we are doing. Code reviews. So main result: developers merge faster. So you get a response from a pull request faster while working from home. We asked people, and they say that they tend to allocate time for doing code reviews at the beginning of the day, or etc. And then they also have more focus. Nobody's knocking on your door asking for a question about how do I do this, right? So you can switch off communication, do code reviews, and then it's not that it's faster by an order of magnitude, but people is faster. Then we analyze daily routines. This is Company A. What we observed is that in Sweden, more proportion of commits on the afternoon, a slight shift on the day, right? We stretch it a bit, working more in the evening. What we also observe is that there are fewer lunch meetings, and that happens, and also people answering Slack and communicating during lunch and late on the evenings. In Company B, we have also some interesting findings. So nothing changed really in Sweden, more or less the same thing about lunch stuff. But what we observe is that India, people tend to work much longer. And when we ask people, they say, yeah, we don't need to commute 2 hours, because in Montreal, it might be half an hour, but in India, they might be 2 hours to reach office, right? And then they tend to work longer, and also they tend to have meetings with Sweden, face-to-face Zoom meetings, and that's why they need to stretch. So that was an interesting finding. Then we analyzed meetings. This was something I had to recheck like 3 times, because that was at the beginning when we didn't know about working from home, the first 3 months, because this has been something we have been doing since the very early, is that the recurring meetings were more common than non-recurring meetings during the pandemic. And it was like, why? I mean, I expected people trying to do ad hoc meetings, but that doesn't work really, because you cannot know when people is free. And then you start booking meetings that happen every week at the same time. And that's a pattern in every organization we have studied. So no big changes, more. So people that had a lot of meetings, but a lot, had fewer, but for the people that had none, now have 2 or 3. So nothing really serious. What we see is that the time for meetings decreased. This company also put in place a policy recently that you are not allowed to book 1-hour meetings. It's 50 minutes to avoid Zoom. So being sick of Zoom, because you have end-to-end meetings and you don't even have time to go to the bathroom, right? So, and they are now putting that policy in place, 50 minutes or 1 hour and 50, etc., to avoid, but booking them for more than 1 hour and a half is almost impossible. Slack communication, this is something that we could have predicted, but I mean, Slack communication in public channels grew exponentially, I would say, at the beginning, and then started to decrease and become more normal, but an average is bigger than before. And what happens with TD and quality? If we can use TD as a proxy for quality, we did this study in another company with more than 800 engineers, and we use SonarQube data, TD, remediation time, code review data, and commit data to start understanding, trying to understand what happens. And what we see is here is TD minutes introduced per week. So the more, the worse. And then we started looking at how TD accumulates. And here you tend to think, oi, this is growing fast, right? Or faster when working from home. But if you then put in the equation the growth in size, it turns out that in 2019, it was kept under control. And in 2020, it's growing much faster, right? When we ask developers in a focus group, they say, yeah, this is because in this component, although we own it, this is the team owning the repo, we are only the gatekeepers. We are not the developers, really. All others are developing stuff there, and we are only the ones that approve pull requests. And then we look at other repos, and for other repos, we see that the owning team is the main developer, and then things are look more or less the same. And then what we learn here is that also when looking at individual commits, we cannot find any difference, really. The minutes introduced per commit doesn't change. We observe differences in the patterns in how it's accumulated per week. And these changes are statistically significant, but we are trying to extend the paper with this analysis and submit elsewhere as a journal paper. But one of the findings from focus groups is that ownership diffusion, what we call ownership diffusion, that means that you don't really own what you are supposed to own, can be a better explanation for faster accumulation of TD. And then we said, wow, then we need to try to measure ownership versus contribution. Ownership means I'm the formal owner. Somebody says, I own this repo or this component. And contribution is whether I'm the person that works more on that stuff or not. So we did an analysis in company C, again, and we are currently replicating in company A, which is the big one with 2,000 engineers. And what happens is when you start putting things together, for example, here we are putting repos and Jira tickets together, and 2 nodes or 2 repos are connected when they appear together in a Jira ticket. This is a mess, right? So there's nothing you can really say. And this can be even worse. So this is a code review graph that shows not individual developers, but teams. Each dot is a team. Each line is when a team is reviewing code that the others have authored, right? And when nodes or teams are clustered together, it's because they belong to the same sub-organization. And when they are apart, it's because they belong to different organizations. So here you can see that some teams are really connected to other teams in the other corner of the organization, which is not efficient, right? And so strong interactions here, we are not plotting the weight, the strength of the link, because it's very messy. What I want to show is the complexity of the problem. And here we are only considering connections for more than 5 code reviews. And this is the technical dependencies on this organization. It's a microservice architecture, which is Kinda constellation. And the size of those dots are the size in lines of code. So some of those are not micro. And this is only portraying backend connections between services. And then we did a ownership versus contribution model that has been accepted in ICSA, New Ideas and Trends, this year. And what we do is that we put several metrics together: number of commits, code churn by developers, the code complexity by each developer, ticket complexity, number of pull requests, number of tickets, and then we see which team is leading each metric. And when the team that is leading one of those metrics is not the team that owns, we say it has an ownership problem. Whatever this means, we are only trying to understand whether there are misalignments. So we analyzed 267 components or repositories, and we found 193 misalignments. We validated the results by doing a focus group, and we inspected 10 repos. And all of them were identified correctly, right? For all of them, there were some explanation. And one explanation, which is for me super interesting, is the backpack concept. I move from one team to another, but I cannot get rid of the responsibilities I had before. Therefore, I need to continue contributing to the old repo or component. And I mean, it's owned by the wrong team then, right? And where are we now? What are we doing with this? I said this connected repos with the tickets. So we are putting together architecture and organization, and we end up doing super massive black hole research, right? Black holes has accretion disk, which is the border or things that are not close to the black hole. The event horizon is really the border when you start getting attracted. And then we have the singularity, right? The core of the black hole, and is when you are really attracted to the black hole. And this is a plot of company C. In red, we have task dependencies, so Jira tickets that put together 2 repos. In black, we have technical dependencies, service dependencies, code dependencies, which is when in Java, A imports B, and then Go dependencies, because they also have some Go components around. And it looks as a black hole, and it behaves as a black hole. So in the accretion disk, isolated repos, no dependencies, nothing really, there's no problem there. However, in the event horizon, you start having repos with smaller dependencies, mostly owned by the same team as here. All dots are blue, belong to the same team. Small propagation problems between them, so not really dependency magnets, but if you animate this plot, and we have done it, you see how you start attracting repos. And the problems, TD problems, can be fixed there easily. And then we have the singularity, which is dependency magnets, both from task point of view, Jira tickets, but also from technical point of view. So there are repos there touched by 13 teams or 20 teams that had 200 other repos being imported, and that are shared in 200 Jira tickets, right? That's a problem. And what happens is that repos in this area get attracted because you start importing more stuff to try to get rid of some problems, and the thing is getting worse and worse and worse. And problems there need much more attention, because on top of it, if it is on 200 Jira tickets shared with other repo, everybody's reading that code. If you don't have clean code there, you are going to be damn slow, right? And we hypothesize here 3 scenarios. We have 2 repos connected by a technical dependency and organizational dependency. That's what you can expect. So something imports A, and is also, so A imports B, but is also together with B in Jira tickets. That's what we can expect. But problematic case is when the repos are not owned by the right team, then it's going to be at least a 3rd team involved in the business. And then if you think on code reviews, you are slow there. Then scenario B is technical dependency between A and B, but no organizational dependency. Really nothing happens. I mean, it's what you can expect. You import data or you import code, and yeah, you in task level, you are never involved in both in Jira tickets. One can think, can we improve the architecture to remove this dependency? Well, that's another issue. In the scenario C, it's no technical dependency between A and B. You don't expect them to appear together, but they appear together in Jira tickets, in tasks. And then you are not writing the code for the other team to read it. And then is when the murders also began, right? So people is touching your code, you don't expect that, and the other team is not only slow in writing the code, but also you are slow in reviewing code. And this is problematic also. And the big question now is, so what, right? So what is that? We want to help organizations in prioritization of TD, where you need to focus, in which repo shall we start? Higher number of technical or task dependencies seems to be something to look at, or these low ownership repos that there are 13 other teams touching that repo. This is probably where you want to start, because if you make people read code in an easy way, you will be faster, because we shouldn't forget that 80% of the time we spend developing is reading others' code. So I think this can have an effect on organizations. And we are now in a big project, or envisioning a big project, trying to analyze whether misalignment explains differences on lead time and productivity, etc. And now you can ask questions regarding black holes if you want. Thank you for your attention.
Thanks.
Thank you very much. That was incredibly interesting. So, yeah, you can make the data say lots. I mean, there is a lot to exploit. I haven't gotten my head around all of it, but I have a number of questions. But I will open the floor to Ghazlan. Go ahead.
Okay, thanks, Javier. It's very interesting, and I'm glad you used the different tools. You targeted different kind of data. One of the tools that you targeted is SonarQube. It's a technical depth as data. And I was wondering, for the companies, in order to get a sense of what we have as a result, did you take into consideration the different languages, different paradigms used within each company? Because my experience with SonarQube is I use SonarQube to compute the technical depth on JavaScript and on Kotlin. And it's surprising how it can give very wrong data. Because
there's a paper about how wrong it is. How wrong.
Yes. Okay. So that's my question. Somehow, how far in your analysis did you go into looking into the different context of each company regarding the languages there? Because sometimes what's considered as a code smell or a problem in one language is not the case in another language. And sometimes, for instance, JavaScript introduces some very weird ways of doing things. So that's I'm wondering if you did take that into consideration.
So yes, of course. Well, not of course. We can make mistakes as well. So yes, we considered that. For the paper I'm reporting for Tech Debt, we focused on Java-based repos only to compare. And we are, another thing is, I'm never tempted to compare companies, right? So I'm trying to compare peers with peers and apples with apples.
Okay.
Now we have another project in which we try to analyze the effect of ownership in accumulation of TD.
Okay.
And there we are gathering data from different languages in the same organization, right? But what we are interested in is on comparing the growth per line of code, right? Is it growing faster or slower? And here the challenge is we will only compare Java with Java and PHP with PHP or JavaScript with JavaScript. We can never, combine them together. And we agree that it's wrong, but I must say also that this company they were using Sonar before we arrived to the company. So they were installing Sonar when we arrived. Yeah, they were concerned about TD and they kind of wanted to work with us. And then we started using their Sonar data. So it's not us collecting the data, but it's them collecting the data.
Yeah, okay. So in all cases, you the data was centered around Java code.
And also in this study, we were a bit careful and we were focusing on repos owned by only 2 teams. So we isolated the effect so that we can know what's more or less what's going on, right? And then we also asked the developers of those repos what happens.
Okay. Thank you. I let.
Okay. And other questions, Sylvie?
Yeah. Have you considered measuring the software functional size instead of lines of code?
Yes, at some point, I think we have not the functional size per se. I think, well, it's a possibility, right? So the whole thing or the whole idea of this model, OCaml model, is not relying only in one metric. But yeah, and all the idea was measuring the complexity of the code being committed. But yeah, it's a good point. Yeah, I don't know if I don't think there are tools that automated that, right? Or at
no,
least
there are some tools measuring from code, actually, from Java code. Not well. I will have to dig a little to find some. I had a graduate student developed a module for that for Java code written with what you call it, the framework Spring MVC. Okay. Not Spring Boot, Spring MVC, but there are other researchers, especially in Turkey, that have developed also libraries to measure functional size from the Java code. And because even sometimes I have like mixed opinions about looking at code complexity, because sometimes it's a blessing and sometimes it's a curse.
So this is not coming from me. this is coming from a senior architect from Ericsson, saying that the best proxy for complexity is size, actually.
Yeah.
So there are plenty of metrics, but at the end, one of the best that best correlates with actual size is lines of code, pure. So I think it's a good point, but I think it's a good point to measure in particular repos to try to understand whether there's a change. But in other organizations I'm studying, they are so diverse that having a metric that only works in Java in one particular
application domain,
one particular framework, it's pointless. So if they cannot agree on using the Java the same way, right? So it's reality is challenging, I would say.
Yeah, and it's making it difficult when more and more they diversify the technologies they're developing into, and comparing, let's say, Java with Python is comparing apple and oranges. So it's a good thing you narrowed the scope to only Java. So at least you have a good comparison. But how about the application domain or application type, where were those all web application, or some mobile application or client server? Or
so the when I was talking about TD and alignment, I'm talking about a system that is a cloud-based system that works in it has a front end in JavaScript, etc., then has the backends in Java. The company in which I'm replicating now the study, it has well, and in this company, the first company C also has mobile. There are mobile repos, although we are not studying them yet. In the other company, it has everything. So, yeah. So, and then is when it comes the problem of we cannot be so picky. We need to be super simple in the metrics we use, so that we can use them consistently, regardless of the programming language, framework, whatever. Because we might have even problems of having the same way of working in Jira, for example, to measure Jira tickets, right? So, and that's challenging, yeah. And that's why measuring the volume of code that we have improved OCAM now. Instead of measuring the proportion of code being written or committed, we are measuring, I don't know if you have heard about Git blame, who wrote each line of code. And now we are measuring, okay, from the code that remains today, who has actually wrote it, right? Because it's a better proxy, but yeah, but it needs to be super simple. Because if you need to analyze 2,000 repos, I mean, yeah.
Yeah, it's a lot of data.
Yeah.
Thank you.
It's more data you can digest. That's the problem.
But I really like your study. Thank you very much.
Hamid, tu avais une question?
Yes, yes. I have a question about, thank you very much for the presentation, very interesting. About refactoring, and you talk about refactoring, less refactoring somewhere in the last 2 years. Why? And second question is about different kind of dependency between the component or between the repository. You talked about some of them. Thank you.
So when I talked about refactorings here, in other studies, we have analyzed the refactorings inside something that a developer tags as a refactoring. Here, what we studied was the volume, here was volume. Yeah, volume, lines of code in refactoring operations versus lines of code in bug fixings or bug, yeah, I'm thinking on their jargon, so yeah, bug fixes. in new features. And here what happens is that in this organization, they are super strict on tagging commits. So when they say this is a refactoring, this is a refactoring. I have not analyzed in this study, I have done it in others, the refactoring of operations that happen inside. I know for sure that they are committing less refactoring code, right? Or code refactoring operations, but I have not looked at specific operations. Is this what you were asking?
Yes. Okay, second question about dependency. Yes, you talked about dependency between repository, component.
I'm trying to arrive there. Yes, perhaps this is a, yeah, here. Yeah, so what's your question about? Or do you want?
What are the different kind of, you talked about some of them, right? Dependencies, not all the dependencies. Import, export, and
so we distinguish between import dependencies, meaning that you have a repo that imports code from another repository, right? And then for building, you need to build both. And this creates a lot of problems when you try to do some analysis, because you need to compile everything on that specific point of time, but that's another issue. That's one type of dependency. The other type of dependency is service dependencies. Is when this component is calling a service, right? Using REST or whatever. That's another type of dependency. And the third type of dependency is Go dependencies, that they say, we have Go dependencies, those are the Go dependencies we have, and don't ask me because I don't have no clue about how Go works, right? So I have absolutely no clue. This is something that they reported they are interested in us tracing, and we are doing that. I have no clue how they do it or what they do with it.
I'm sorry.
Did you consider here the microservices in your dependency, yes, or not at all?
Yeah, this is the microservices. When I say service dependencies, is microservices. They say, everybody says now that they are using microservices. Although you will be surprised how connected or interconnected they are on the lower level. But that's another issue as well. Yeah.
Thank you.
I'm sorry, Javier, you said Go dependencies. I didn't understand that. What?
It's Go language.
Oh, the Go language, okay.
Yeah, and I have no clue or whatsoever how this works. So
okay. Go is a derivative of C.
I have no clue, Javier. Okay. I have not even looked at it. So
okay.
I need to look at it to avoid this type of questions.
Noel has a question.
Yes, hi. Sorry,
hi, Noel,
I'm eating. Hi, Javier, how are you? I open my camera. Hope you're doing well. Happy to see your work. Very amazing, interesting. Actually, I have a question regarding the bugs. Did you consider different kinds of bugs? Because I guess vulnerabilities might be, the developer may behave differently regarding the types of bugs, I guess.
So when I'm working in this graph of volume of code being produced for bug reports, here I must say also that in this particular organization, they consider bugs also internally reported. So that has not been reported so they mix bugs reported by the customer and bugs reported by the developers. This is one thing. And I have not looked at it. So this is when somebody says this is a bug fix, we believe it, because it's a tag on the commit that says this is fixing this bug report that we have in Jira or in whatever. And then when I'm talking about bugs in technical depth tools, this is very tricky, because it's not the manifestation of a bug, but a static analysis saying this might be a bug. because you are misusing memory, or it should be dynamic calling, you are using static, these kind of things, Sonar says is a bug. And this is very, very tricky. We understand that, but when we report this in the papers, we say, yeah, we know it is what Sonar calls bugs. We know some of them might not, but this is what it is. I mean, we are using tools to measure that that are widely used. So, but yeah, that's another thing to try to measure. And to be completely honest, in some organizations, we have access to the bugs, the actual bugs reported and where they were flagged. So we can try to take a look. I tried to take a look in 2019, and it was so big project that we had to move to something else. So it's something we couldn't work with. Yeah.
Because they may behave differently depending on the kind of bugs. So I guess for vulnerabilities, they might be more proactive in fixing them.
Yeah, I have a paper that I didn't want to talk about today. And it's about so how you treat bugs, vulnerabilities, and code smells in open source and in some organizations. It has been published in journals on software maintenance and evolution recently.
Okay.
What we saw is that
go ahead.
We saw the survivability of each type of code smell or bugs or vulnerabilities, and we compare them in between open source and closed source organizations. Although I try to avoid now doing open source research, but I think that was relevant, and we saw different patterns. And now Sonar also has invented a new thing, which is real vulnerabilities, not the ones that they are reporting now, but real. Because now they are also doing syntactic static analysis to detect vulnerabilities, not real analysis on vulnerabilities. But now they have improved that as well.
Yeah, for sure, you are lucky to be able to do research with companies and having access to that data. Actually, referring to your paper, while you were presenting, I had a look to your recent paper just to see what you are doing right now. And one of the paper was about the cultural bias in agile teams. And
yes.
I did not have a look to it, but just the title, and it seems really interesting. And I was wondering if cultural bias may have an impact in the way people, they work from home and at work, and what kind of cultural bias, and specifically women, how they behave working from home with children and trying to, so that's a question.
So this paper that reports this study contains some interviews in which we touch upon, we don't touch upon the gender per se, but we have some quotes. This paper is archived, but what I wanted, we submitted to CACM, communications of the ACM, 5 months per review. We got a minor at the beginning, we fixed it, another minor asking us for more data saying, we see you have access, why don't you bring more light? And it's 1.5 years, it's not, because this paper was about the transition to working from home. And it has been hostage. We have withdrawn the paper and submitted to GSS in practice. Because, we feel that they don't want to publish this. And having this note as a side, we had quotes of that, and also we did. So as you have seen, I was talking about people in India commuting, having shorter commutes, etc. So we did this and we analyzed this. There are some, although I don't know how much is reported, there were some stereotypes of, people without kids, people with kids, so young engineers that recently joined a company, a super cool company, and they want to go to the office every day. versus the people which is tired to drop the kids in the kindergarten and prefers being at home. Yeah, so we have done not super deep, but this has been also touched upon in this paper that is archived, and we hope it will be soon published in GSS in practice, because I think the paper is ready. So either you want it or not, but there's nothing else we can do now. So yeah, and we are preparing also a super big TSC paper or TOSEN paper with this data, because we have tons of data about it.
Yeah, definitely. Okay, thank you, Javier.
Thank you, Noel, for your question. Yeah.
Excellent. Any other questions? So I'm always slow to understand. I want to understand the black hole concept a little bit better. So one of the issues you mentioned is when responsibility and ownership do not align.
Mm-hmm.
So that I got. So can you go over the black hole concept again?
Yeah.
One of the reasons I'm asking this, actually the next talk, and you will probably enjoy it if you can join us at 6 o'clock.
Mm-hmm.
The next talk is about somebody who works at the company, and he will talk specifically about all the problems created by open source package dependencies. He will talk about quality, security issues, etc. So
I have one of my students also is complaining a lot about that, and we have a study done about these 3P. They call it 3PPs, is 3-part products, and how you incorporate them, and what you should do to incorporate them before. Okay. I mean, before you decide. Yeah, but this Log4j, this guy was crazy about it, because they were doing a bank application, and they were doing using Log4j, and Log4j was calling the cloud to ask for stuff when you were validating a bank account or something. So that was not even funny, right? So yeah, so go ahead, have it continue. Sorry for interrupting.
Yeah, so just if you can go back to the graph and explain what kind of project is attractor of trouble. What's a black hole in this context? If you can just go over that concept.
So the black hole is when you have repositories in the singularity, mm-hmm. which means that they are dependency magnets, technical dependency magnets. So they are connected to every other repo.
Okay.
And usually, and this is super interesting. Perhaps this is something I can say. Even the names of the repository are the same in two companies.
Wow.
Completely different domain so everything is different.
Yeah.
Users, login, users' rights. So those are dependency magnets. Everybody's using them, right?
Okay.
Then they also tend to have ownership problems. People tend to go there, introduce code. The team that owns that repository is like, they don't even know what they are doing, right? The other team. They say, yeah, looks fine because the structure of the code is pretty and blah, blah, blah. And then they don't have control over it. And what happens here is that, so they are connected technically, they are connected. So imagine this user rights. They are connected to, in every single or every second Jira ticket, they are connected with other thing. So they are connected to everything. And what happens?
They are at the bottom, they are at the source of a dependency tree.
Yeah.
So everybody depends on them. It's not that they depend on everything else.
No, exactly. And then all of a sudden you start attracting, so repositories that were on the border, you start adding stuff, and then you start importing more code to make it simpler, thinking you are going to make it simpler, and you don't. And on top of it, you start having those repos involved in more tickets. And then those repos start getting attracted to the center. And this is the black hole effect.
Okay.
So the repos in the event horizon start being attracted to the center by dependencies. And this is what we have observed when you animate this over time.
Okay. Interesting.
This is the concept of black hole.
Yeah. So this really aligns with what my friend Stan Zajdel, he's the next speaker. He has very strong opinions about how frameworks should be built, and he has strong opinions about the log4j problem. He said,
I can put him in contact with my PhD student. I can put him in contact with my PhD. Well, my PhD student is a senior architect in Sweden, in Ericsson, Sweden, for 35 years. So yeah, and he has also strong opinions about it. So they can talk and ventilate.
Yeah. So he must be Stan and my age. Stan and I figured when we talked, I figured we're probably the same age. So yeah, so get your architect to attend, and I would welcome to. I would love to have them argue at the next seminar in 2 weeks.
I can try to invite my student or the architect in Ericsson. For me, if you send me the video, I will go through, because this time of the day for me it's a disaster. Yeah. The kids should be around in 10 minutes.
Yeah. Okay. All right.
This is why he's silent, because they are not here.
Yeah. Excellent. Last question.
Okay.
A last question to wrap up. Noel, is that a new question, or it's just you didn't lower your hand?
So no, okay. Sorry, I forgot to
lower your hand. Okay, that's fine.
Abdel, I was missing you.
Yeah, well, we have another meeting in the department, so this is why I left them. I told them that I will be back just to see you, my friend.
Nice to see you. I was hoping to see you. I didn't know what.
Yeah, they have a bad habit in their department.
Yeah,
on Wednesday at noon.
Yeah, and we have the meeting is still happening now, so
all right.
I left them.
Okay, it is recorded anyway, so you'll have all of these discussions, including me shouting at my son who just walked in. So Javier, this was very interesting. Thank you very much for this talk.
Thank you for the invitation. It has been a pleasure and a super nice discussion at the end. I have enjoyed quite a lot. It was long ago I was not enjoying that much in a distance talk, so really nice to be here.
Excellent. And so, I'm glad you're able to work from Spain. I wish I could work from Tunisia, but
I mean, it's so bad weather, plus 20, and yeah.
Yeah, you should work in Spain from like November until about March.
Yeah, that's what I'm trying to do, actually. Yeah, we are planning to go for vacations to Sweden in summer, but no, not in the winter. Yeah,
not in the winter. Yeah, the long dark night. Very good. So thank you very much.
And, thank you.
Thank you. I will send you the slides. I need to fix a couple of typos and one link that I say is archived, but we have decided that we cannot archive that paper. I will put it in my website and I would link it. Therefore, you have access to everything.
Excellent.
Thanks a lot.
Nice to see you, Javier. We should talk someday.
Yeah, we should talk. Bye-bye.
Bye. Bye.
Bye.